Okay, everyone. So welcome Stockholm and welcome London as well. Welcome to the first distributed C++ meetup. So I'm going to explain a bit about this concept of distributed meetup, and then after we're going to have the talk. So why are we here tonight? It started when us, the Sweden C++ meetup group, noticed that there was a lot of very interesting other C++ group in Europe. They have a lot of nice ID talks and knowledge. And since we are not as big as the CPPCon or Meeting C++, we cannot bring them physically here with us. So we had decided that maybe what we could try to do is to have them using a visual conference tool. And so what we did, that we contacted the London C++ group and asked them if they were willing to give it a try for this concept. And Phil Nash, the organizer, said yes. So here we are tonight testing this concept. If the concept is successful and you guys like it, we might try to extend it and to have some other C++ group with us. We could have like group from Berlin, for instance, or from Barcelona. We have some King offices there, so we could have the visual conference to link to be able to have a meetup with them as well. I think this applies both for the Sweden C++ group and the London one. We need some speakers to be able to do some nice events. So if you have anything that you would like to share, any experience that you had or tool that you use that you would like to speak about, then please contact us and we will try to find you slots to have your talk in one of the next sessions. Tonight we have two sponsors. The first one is SwedenCpp, and the first one is JetBrain. So if you go on Twitter and write hashtag SwedenCpp and hashtag CLion, you might get a CLion's license for free. CLions is a nice C++ ID. I personally use it and I like it quite a lot. So be fast and try to get that license. We also have another sponsor, which is King. So King is hosting us nice, as you can see, but they also provide the food, the drinks, and the facilities. I am working at King. I work on the game Candy Crush. We have a lot of other mobile games, like the Bubble Witch saga franchise, for instance. And all of our games use one language in common, which is C++. We use it for the games themselves, for the game engine, for our tools, even for web version of our games. We use mscripten to compile C++ to JavaScript. So we really like C++, and that's why it felt pretty natural for us to host this event tonight. If you want to know more about King, I would suggest you to go to one of these two websites where you can discover King and look at our open positions. We have a lot of different positions in C++, but also some other languages. If you have some specific question, you can also reach any of the King employees who is attending the event tonight. I'm sure they will be more than welcome to answer your questions. That's it for me for tonight. We are going to have 5 talks from Sweden C++, and after roughly 1 hour, we're going to switch and we have to have some talks from the London side. Since we have a tight schedule, we won't have the time to have question and answer. So we will have an open question and answer session after the talks. And that's it. So we are going to start with Björn, who is going to talk about variant of recursive descent parsing.
Thank you. Let's see if we find this. Thanks. Okay, so I'm going to show how to write a very simple recursive descent parser that actually implement this grammar, simple mathematical expression parser. The problem doing this is that parser generators suck. That is the normal thing to do is start thinking about the grammar, you start thinking how to generate it, and this actual code is from the manual for GNU Bison. And sure, if your grammar is complex, by all means use a parser generator, because then it makes life easier. But for a very simple grammar like this, it just doesn't make sense. The distance between the code you write and the code that you have to try to understand errors in will be too large. So it's just hopeless. Yeah, parser generators suck. So then you may think, all right, I know, I'll just use a lexer then and write my own grammar. But lexers suck. Typically, I have this. You have some enum for your tokens and some horrible union for values that are associated with tokens, and you have to write code like this last line where you just hope that you get things right. And if you don't, well, life is not too good. It's difficult to debug. All right, enter C++ 17. So the variant is, well, we can see it as a union. So in this case, we can say that our type V here is a union of int, string, bool, and a list of ints. Meh. Not very impressive, I thought, when I first read about it. One cool thing, though, is that it knows what type it holds. It's a tagged union, so it's impossible to try to get a value of the wrong type. So this itself is not too impressive. But a companion to it, stdvisit. This blog post made the rounds about a month ago, roughly. I won't go into it, but please read it. It's very, very much worth reading, actually. I'll touch a little bit of one of the problems. But what stdvisit is that we can call visit on one or several variants and a visitor object. The visitor object is something that has overloaded function call operators for each type that it holds. And in this case, I used auto as one of the examples to catch the rest that I don't care about or consider an error that I want to report. But this is uncool, because the distance between the visitor code and the use of it is too far. So I'm not happy with it. But observation. A lambda is an object of class type which has a function call operator. And a lambda can be a base class. Okay, I feel evil green horns coming up. You can use a lambda as a base class. This is cool. So what we can do is this. So I have a class template overload that takes a plethora of template arguments that it uses as its base. The constructor just forwards whatever it gets into its base classes. And then we use C++ 17 variadic using to bring these function call operators into view so they are available. And another C++ 17 feature is that if you construct a class template and the template parameters are deductible from the types of the constructor call, then you don't have to state them. It's deduced automatically. So in this case, X is an overload of two function calls, one with int and one with string. So that is neat. So we can use it like this. Call stdvisit of this overload of lambdas. Again, use auto for stuff we don't care about, and an object of a variant type. Cool. So let's go back to the simple math expression parser. So some useful types. We have a simple character template for the single character tokens like plus, minus, parentheses, and what have you. Numeric literal should hold its value. An identifier, I wanted this calculator to be able to store variables by name. So an identifier makes sense. I use string view in this example. Could be a string or whatever. And other types, remember and forget, or for storing and dropping variables. And everything that we don't care about is an exception. So we say that we have a token type that is a variant of each individual token. A lexer can look like this, something that looks ahead and gives you the next token without consuming it, or one that consumes it and one that just drops a token. And again, exception thrown for things that we don't like. So now you can see very clearly the code here in all its glorious detail. We can zoom in on one thing. The cool detail, though, is that this is the entire parser. Missing are 3 functions that are related to the storing and retrieving of named variables. But this is a parser completely. So let's look at parse factor function. To see, get the next token, visit of what to do with an identifier, look it up with a number, return the value, etc., etc. And for things we don't like, throw an exception. Okay, I don't really endorse throwing string literals, but hey, slideware. Another example, parse parenthesized expression, where we just continue with parsing what's left after the parentheses and then check if this variant actually holds a closing parentheses. If not, we're not happy. We, again, report an error. So I think that is cool. Stud variant and stud visit and the overloading of lambdas make life really easy. The same example can be made for, say, communications protocol, where you have different types for each message type or something. That blog post I referred to in the opening, the problem is this overload class template that I showed how to implement. It would have been kind of handy if the standard included that or something similar. That is it. This GitHub URL is not available right now, but it will be tonight when I get home. So you can look at the sources if you want to play with it. Otherwise, you have information for how to spam me should you want to do that. Thank you very much.
All right. Next, we have Mikael.
So, who am I? Mikael Rosbacke, software developer like C, C++, that kind of stuff. State machines, going a little bit old school here. We have seen them before, so one more try to actually be usable. So you all done the switch case. You have a hierarchy that you can set up, a state chart if you want to be strict on names. So how do you do this in C++ in a fairly decent way, more or less? So I've written a small helper. I wouldn't call it library, a C file, a CVP file, and a header file. The scope for this is more or less make it easy to write these state machines. There's no code generation tool. I want entry actions and exit actions, support for that one. Hierarchical, so when you switch state from one place to another and you pass down and pass up, all that should be automatic. So that's really good to have, I think. Microcontrollers, I like them. I want to be able to use this there. So no heap allocation after construction. And intended for this sort of application logic, not just hopping around and decoding a protocol and that kind of stuff. So it's a little bit overhead, but it should be able to give you something for that overhead. So what's not in scope? Thread safety. You can put on a thread safe queue on it, and you can do that. Should more or less take care of that. There is some common data structures inside, but they are const, so that should be fine. Continuous processing, that's also out of scope. Just insert events to do that. Time handling and states. If you know UML, you can have this and states with several states are active at the same time. That's also left outside. So just do 2 of them. And yeah, that's more or less out of scope for this. So the basic idea, the classical use an object or a class to model a state. Some nice benefits. You can use the constructor for the entry state, the destructor for the exit state. Very easy. When you start thinking about this, you kind of start wondering, can I use inheritance to model this state hierarchy? And no, you can't, because the lifetimes are different. So it's more like a stack of objects where you construct the states on top of each other, and then you destruct them when you go down and construct them again when you go up. The events, I like the model where the events are an object where you can put in a queue, you can copy them around. It's not a function call that like the state pattern does. It's a design decision. I like it this way. Run to completion semantics. That's the important one, I think. When you start running your function, you want to be sure it ends before you enter some other state and when you call something else. So that's why I include a little queue here to take care of serialization of event objects. And the delivery is going through this event function that every state class needs to have. So how do you use this? I hope my code is readable on this. You have a class, my finite state machine. You call set start state, that activates it. All the entry actions or constructors are fired up till that state, and you're ready to go. Then you just post event until you're done and everything destructs. How does this class look like? It's an ordinary class, nothing special. It inherits from this FSM base. That's part of the framework. You have this myFSM desk or description. That's another class you're using to describe the structure of your state machine. I'll get back to that one. Other than that, there's nothing special in the actual state machine class. You can have some additional data that's accessible from outside or from inside the states. So that's a good place to keep stuff that has the lifetime of the state machine. So now if we go into the state machine itself and look into a state, how does that look like? Class MyState. It needs to inherit from state base. That gives us a couple of functions you can use in your state class. It's also templated on this description class, so you have all that. And you have a dual representation here of states. One is the actual class type. The other one is an enum enumerating all the states. A little bit of a violation of one definition rule, or just the dry rule, I should say, the dry rule. But I need both to be able to calculate on it on runtime and at compile time. So both are needed. The constructor is a little bit of boilerplate. I need to pass arguments down to the base class, and since this framework is actually constructing these objects, so I need to pass the args down. Other than that, you're free to put your entry event code in your constructor. Nothing special in the destructor, just your exit code. And then the main functions are handling this event function, where your event type is input. That can be a primitive type like an integer or floating point, or if you want that. And then you do something interesting. And if you want to switch state, you do this transition function. And you go to the next state. true and false, depending if you want to continue down through to your parent states or to a lower level, sort of. So that description class I talked about, it ties together the event class, my event, the finite state machine name. It should be a state using states equal, or state ID equal state. I missed that one. And then final as setup states function that describe the structure, how all these states are tied together. And it's just a number of add states function calls, where if you only have the state 1, state 2 here, they are at the root level, level 0. But if you put it a second argument, that's the parent state, and that's how you go up a level. And you can do that recursively up to, yeah, well, there's no set limit for it. So that's the basic use case of it. What does this buy you? What can you actually use this for? Or what does this offer you when you want to write your states? In the state base that you inherit into your states, you have the transitions. You can do it either by type or by this ID number. So you can do it runtime calculated if you want to. You get a reference to your state machine, so you have all the data that you got stored there. And you can reach down to your parent state if you know its type, which you should do since you're the writer of the state machine. So you can access data down there. And that can be useful if you want to have data that has longer lifetime than your current state, but you're a number of small states that cooperates within a larger parent state. And once again, going out to the outside, looking at the state machine, what does that one offer? You can query the current state. You can, once you know the current state, you can actually deduce the type of the state, and you can get a pointer to it that allows you to inspect what's going on inside that current state. Active state in this case, then that's allowed to go down all the way to root if you're on a higher level. So you can any of those objects. And the last part that's written but not in the code on GitHub is set state change callback. So you get a callback each time you do some kind of stage jump in this one, and that can feed another state machine if you do it. You want to do it like that. So that's how you use it. Some mechanisms that I'm used when writing this one. Placement, new, and delete. So when you construct and destruct state, there's no memory allocation going on here. You set up memory so you have it for the maximum size for each level, and then you do placement, new, and delete, which is just function constructor and destructor called, more or less. So it should be fairly cheap. Set start state, first time you call it on one state machine, it will set up sort of a data structure that describe how this looks. But that's const declared and then shared by everyone using this function starting object mechanism. State classes are not polymorphic. Sean Parent had a nice talk on how to avoid that one, so I tried it out and worked great. Current status, available GitHub. License to be defined, but MIT BSD is probably the one I'm going to go for. Fairly open. Prototype quality, I've used it for my own projects. It works fine. It's still under development, so the interface is sort of settling in. I think the state classes are fairly set by now. What's going to change is more on the state machines, some added functions, and how the description class is handled. And it's inspired by, if you know, Mirosamek has written a lot about state machines using C functions and static functions. I borrowed ideas from there, but implemented it here. That's all. Thank you for your attention.
Now we have Simon, who is going to come to present the type factory.
Hi, I'm Simon Pettersson, software consultant at Dreik Technology. We hosted this event a month back, I guess. All right, I'll dive in. Who knows what this is? You can? I can tell you, this is ancient scripture or something like that. It's macros. And if you buy several million microprocessors, this is what they'll give you to base your type-safe, nice C++ code out of. And I like really old computers, which are like 30 years old. So I decided to try to make something better for one of these old computers, which is an Amiga 500. So these macros, since you can read them, what they do is they let you read and write to memory mapped hardware devices in the computer. And it's just like bit shifting and macros going on. So what if you can do something like this with constexpr? So you have this lookup table, which works in compile time. You have an enum you can use to look up a register, and you can use read or write functions on this type, on this variable. And this read or write functions, they can check, they can do static analysis before you even reach runtime. So in order to build this, we need this. This is old. We got it 6 years ago with C++11, but it's really useful. This is code from a really big library, from a very big company. I'm not going to mention the name of it, but it's Google. You can rewrite it like this, just with this simple keyword, auto, which makes it like, what is it, like a third, the code? So should we use auto all the time, like everywhere where we can? Well, yeah, I guess. Like if you take this square function, for example, it doesn't care if it's 8 bits or 64 bits, or if it's bananas or apple. The only thing it cares about is that you can multiply this number with one of its own type. So this is gonna be like, it's gonna work for everything, which has the operator like star, whatever it's called. And also it enables us to use lambdas. Who knows? Who can tell me what a lambda is? Shoot. All right, no, it's just it's a struct with a function. What is it called? Operator function call, right? Yeah. So it can contain state, and it has a type. In this case, when you use this lambda syntax, it's a generated type, so you can't really type it. So you need to use auto. And this is, of course, since you're C++ professionals, you knew all of this already. So why am I telling you this? Well, to do factories of lambdas, you need auto. It's essential. So imagine you have something like a lock, and this lock, you need the right key, and if you use the right key, it's going to return you a value. If you have the wrong key, it's going to return nothing. So you have this lock factory, make lock. It takes a key and a value, and it's going to return a lambda, which if you give it the correct key, it's going to return you a value. If you give it the wrong key, it's going to return you nothing. Is this clear? I guess. So you use it like this. You have a key, 42, you have a value, 1000 plus. You call the make lock function, it's going to return you a lock. And you see the keyword to the left? It says constexpr, and that means you can do this in compile time. This doesn't even reach the platform you're targeting. Like it doesn't translate to assembler instructions. It just happens in the compiler. So you can do static assert since it's compile time. If you call my lock with 84, which was the wrong key, the key was 42. So 84 would return nothing, and 42 would return like the value. All right. What if we have one key? We have the key, it's 42. Then we have like a big pile of locks. And then we want to find which lock does this key fit, and then we want to retrieve the value. And if there's no lock containing, like matching the key, is going to return you nothing. In this case, we need to construct like a tree of locks. So you arrange the locks in a tree structure. You have all the locks as leaves, and then you need something to connect it all. And for that, you use a branch. So this make branch factory function, it takes a left subtree and a right subtree. So the subtree could either be another branch or it could be one of these locks. So it's going to return another function which has the same signature as the lock. So the branch is going to return you another std optional, which could be either nothing or a value. And this function is going to first check the left subtree. If it returns a value, it's happy, it's going to return you the value. If it doesn't, it's going to recurse into the right subtree. If you put some makeup on this, because that's pretty easy, but to make it usable, it gets kind of hairy, at least for me. I'm not like the best programmer in the world. So you could end up with something like this. So you have a lookup factory, you pass it this, you have another map factory which produces these values, the locks. This is like the make lock function basically. And you map, in this case, A to 13, B to 55, C to 87. And then you can perform lookups using the square bracket operator thingy. And then you can use it in compile time. So you can make a native array of 55 items, like in this case. So going back to the Amiga. The Amiga has a 24-bit address space. And then it has restrictions on all these registers. So some registers you can only read. If you try to write to it, it's going to crash. And some registers you can only write, so it's going to crash if you try to read. And with macros, you have to just do the correct thing all the time. If you use C++ 17 type safety and all this jazz, it's gonna crash in compile time instead. So we map this. The register is an enum. So each one of these are named. I think PRA is something like the mouse button input or something. It's a byte. So you tell it, well, this is a register. It has this address. It's 1 byte wide, and you can read from it. So you can't write. And you construct this lookup table in compile time. Then you can use the read function. Since all of this information in the register fits in one 32-bit integer, you can typecast it to a 32-bit integer, and you can pass it as a type parameter to the read function. And then the read function is going to do static assertions. It's going to see, well, can I read from this? Well, if you can, then it's good. Otherwise, you're going to get a compiler error. And then it's going to check the width. And I noticed a bug in this slide because it's going to try to read along from this byte register. So in this case, the compiler would throw an error in this second static assert. But if it's all good, it's going to get that address from memory, and it's going to return the value. So then you can compare. So the bottom section is what you get from the manufacturers of microchips with the macros, and the top one is I wouldn't say, yeah, it's the same code, but in C++ 17, and this has like no overhead at all. So I didn't keep time, but this was if I had time over, I would show this. So this is the compiler explorer. What? Is it time over? All right. I'll just show this. So we create a lookup table. It has one item. It maps the integer 1 to the integer 42. If you look at the assembly code, well, it returns 42, which was expected. Can I? Like this? Yeah. Perfect. So if we try to look up another value, like 2, oh, it's going to throw an exception. And this is like a lot of code for nothing. Okay, what about now? It's going to give you a compiler error. And if we look at the error, it's going to say something about, okay, this is too inconvenient. So I'm just going to talk about it. So what's happening is that there's a throw inside of one of in the lookup function. It throws an exception based on some criteria. And in compile time, if we look up the value 1, it's going to compile. But if we look up the value 2, it's going to reach a branch where you throw an exception. And in compile time, you can't throw exceptions because it's not runtime. So then it's going to crash saying something like, oh, you can't throw exceptions because this is runtime. You're stupid. Yeah. So this is a small library I wrote. I think it's 60 lines minus the license or something. So it's really tiny. And it's here, CMAP. And this is the Amiga BSP example I made using the CMAP library. And that's it. Thank you.
So, thanks, Simon. And now we're going to have Paul, who is going to code live, and it will be about Stud Forward.
Okay, hi, I'm Paul Dreik. I'm going to speak about Stud Forward. So this is going to be a beginner's talk. So Stud Forward was introduced in C++ 11, and it's coupled to move semantics, R values, L values, all that stuff. So I'm going to try to demonstrate with this live coding. See if we can get it big enough. Is this okay? No, oh no, can't see it. Okay, so just clean up here a bit. This is my example program. I have a struct. I have a function taking a reference to a struct. So far, so good. So if I create an object and then invoke f on it and then try to compile, you can see here down at the bottom, try to make it bigger. So see, the function gets called. That's what we expect. So that's good. So what now if we use a temporary object? So this will be an R value. So we get a compiler error. So that's because we have a non-const reference, which won't bind to an R value. So we will add an R value overload. Okay, that should do it. So let's compile and run. Yeah, you can see down here at the bottom that it selects the second overload. So this is good. This is what we expect. So now we'll see, what if we have a wrapper? So in this wrapper, I will invoke f. Oh, crap. No. So let's try this and see if it compiles. Yeah. So the reason for having a wrapper, maybe you want to run f in a try catch, or maybe you want to log something, then run f, whatever. Many reasons. So let's now try to invoke wrap instead of f. So on the L value, you can see down here, everything works as usual. We get the first overload, so that's good. So now let's try the second one on an R value. Oh, I forgot to change it. Oh, crap. I think I'm getting some kind of help here. Okay, that looks better. Okay, so now when I invoked wrap on an R value, we got the first overload. So that's wrong because that's not the same thing as calling F directly. So this is where we're going to use stood forward. So we see this double ampersand, this is a forwarding reference. It was called universal reference, but now it's called forwarding references. So I'm going to use stood forward on T. So what this stood forward does is that it preserves the value category of its argument. So let's try this now. So I have the the L value version. So it selects the first overload. That's good. And we invoke it on the R value. We get the second overload. So now you see we have a generic function which selects the correct overload. So this is what you use stood forward for. So there, if you dig into this, you can go quite deep, but this is most of what you need to know about stood forward. So I can note that you can't use stood move here because that would be the wrong thing. That would unconditionally make it an R value. So stood forward is the right thing to do in this place. So I think Vittorio will speak more about making these generic functions transparent later. So thank you.
And to finish, we're going to have Björn, who is going to come back speak about exceptional type safety.
All right, hello again. Type safety is good, everybody knows that, and exceptional type safety is obviously exceptionally good. Those of you who follow me maybe know that I have a experimental strong type library on GitHub. This ain't it though, as you can probably guess from the grammar, which you may remember from 45 minutes ago. So I thought this stood variant, stood visit, overload stuff, that's it's kind of neat. But what if you work on older code? You work on C++ 11, or heaven forbid 98, or pre-standard, wow. How would you do something like this then? Is there maybe some technique we can use to get this same goodness to match code with types? Throw catch. So if we have a function that throws A or B or C, we can use catch A, catch B, and catch ... to do whatever we want to do. So let's do that. So, simple calculator, the same tokens, the types are completely unrelated. So we can write our lexer such that it returns an error message or throws what it finds. This is useful. And so you can see some lexer example here. If we found a left parenthesis, we throw the token for it. And if we find numbers, we throw them, or we return that we really didn't like what we found. I mentioned earlier how you use a look ahead. So why not use exception pointers to remember where we were so that we can rethrow that thing again if needed. This is amazingly neat, actually. So here we have the full code again. You may note that it's actually a little bit shorter than the stood variant version. So we can zoom in again. So we try to call the lexer and we catch whatever we found, what we like. The same for the parentheses. We just parse the expression, then we get the next token, hope that we catch a closing parentheses, then we're done, otherwise something's wrong. So, the age-old question, return or throw for error. You return something that explains what the problem is, and you throw polymorphic information up the call chain. Thank you.
All right. I think that's it for Sweden. So we are going to switch and start to, well, we in Stockholm start to listen to Stockholm, London talks. So let's do this. Let's do the switch.
Right, hello London and hello Sweden. That's a city versus a whole country. Let's try that again. Hello London, hello Stockholm. Welcome to London. Glad you finished a bit early because we've actually got quite a few talks to go through here, and 3 of them are 10 minutes long. So welcome to C++ London and our new branding. We've got the new logo. Let's move on. Right. So we've got all of these talks to get through, including my brief intro at the top here. And normally, when we run this user group, I do a little bit of news at the beginning. Just going to do a very, very brief one this time, which is basically just our next dates. Now we have some for November on the 27th and December on the 11th. We've actually got talks lined up, just getting the last few details together before we announce those on meetup.com. But just to let you know, of course, we're always looking for new speakers for the pipeline. Also, while we're on the subject of dates, got conferences coming up. A couple of weeks, we've got Meeting C++ in Berlin. I think they're almost sold out of tickets, and they're going to finish selling them on next Friday anyway. So if you haven't bought any yet but you want to go, then now's your time to move. If you missed that, the following week, there's another conference in London at Skills Matter called ADC, which is the Audio Developers Conference. So particularly of interest to people in that particular domain. But even if you're not, it's actually full of really great C++ talks, all about low latency, real-time sort of stuff. So if you have any interest in that at all, that could still be interesting, actually. And then next April, we've got the ACCU conference in Bristol, which is a strong C++ core. Definitely recommend that one. The reason I'm bringing it up now, that's quite a long way in advance, is the call for papers is currently open. So if you're interested in talking, now's the time to put your submission in, because I think it's only open for another week or two. So that's an April. That was all I was going to say, but this email popped up from meetup.com today to say that this group, C++ London, was actually started exactly 1 year ago today. So how about that for coincidence? Well, that was when I created the Meetup group. We actually had our first meeting in December. This is the 11th meeting. So still, that was quite nice. Okay, so back to our talks. Now, for the speakers we got here, just a couple of practical notes. First of all, for the camera for Sweden, try and stand in the middle if you can. So we can also see the screen here. We've got the hand mic, and you'll have my clicker. So you'll have to juggle those two. Hopefully that should be okay. And we're going to be reasonably strict on time. If you don't finish exactly on time, carry on a bit, but we're trying not to push it too much. So I'm going to welcome our first speaker up. Is Dominic here, actually? Ah, there we go. Didn't see you earlier. I shall pass the mic over to you now.
So this is just an idea. So I present this to get some feedback from language experts. If it was a stupid idea or a good idea. That's the part of it. So this is the hard problem. It's distilled down. The question is, can you do a transform of compile time on an expression where all the types are the same? And the answer is you cannot, because there's nothing to distinguish. If A and B are the same, how can you, they're the same type, you don't have the address, you can't distinguish between them. So the idea here is, can I transform A plus A to 2 times A? On the other hand, can I use that same transform function to leave a plus b alone? And this is impossible as far as I know. Correct me if I'm wrong later. Anyway, I think this is impossible. Now, this is my distilled problem. My proposal is to introduce a new keyword, and this keyword would somehow present what is different. So it can't be the type is the same. It can't be the address because we don't know any addresses. So what else can it be? My take is that, well, what's different is position in the file. So where A and B are declared, logically cannot be in the same place, can't be the same column or line of file. Anyway, so the idea is that var ID, this keyword, would somehow present a hash of these three pieces of information. And it can bung into typical expression tree feature like this. I think there's some sketchy parts about this. Anyway, that's the key idea here is that the declarations have to be visible in the translation unit. It can't be externally referenced. But that's fine because with this sort of work, it will be. So somehow, back to A plus A and A plus B, somehow you'd want the type to embed that var ID identifier. So A plus A, well, let's suppose A's var ID was 1 with some number. Well, I can bake into the type that A plus A is referring to the same thing. A plus B is not. The A and B are not the same because they have different var IDs because they've got different positions in the code. Sorry. So what's it like? Well, it's a bit like size of because it's a keyword and it's evaluated at compile time and it returns some unsigned integer. And it's a bit like address of, or the address operator because it expects an L value and it returns something like an address. It's a location. It's the hash of a file name, row, and column of a reference variable. Now, what do you do with temporaries? Well, you have to trace. Well, what do you do with references first of all? We have to trace the const ref all the way back to its actual declaration. But you can do that because it's the same translation unit. So a valid uses would look like, well, you've got C0 and C1, the different values are the same type. Should they match? Well, no, they shouldn't. Should be able to use const ref here? Well, yes, you have to be able to support this. So you should be able to, CR should equal C0 if you're referencing it. And with copies, it shouldn't work. It's a different declaration. It's a new declaration. And invalid uses, well, you can't have expressions, you can't have values, and you can't have types. So presently I have a workaround for this. And it's pretty crude, but actually it does work. So I have to make use of counter, and I have to wrap temporaries or variables with a UQ macro, and it's pretty ugly. Anyway, it works. Why am I trying to do all of this? Well, I've been working on automatic differentiation for about 10 years, and all the tools available are pretty slow. I mean, I'm not surprised that the uptake of automatic differentiation is slow. It's very slow. It's because the tool itself is very slow. So I've worked for some years on trying to do compile time automatic differentiation, and there is some success and a relative performance about order of magnitude compared to current tools. It's clumsy to write all these macros around various values. This is contrived, but to kind of put a bit of flesh on the bones. Well, suppose you've got a function, and you've got the expression tree to its right. And the question is, is the left branch the same as the right branch? And from the point of view of compile time analysis, they are the same. Type-wise, they're identical, but numerically, they're not identical. And this is tedious. Well, it's tedious to work around this problem. From the point of view of just the values C0 and C1, you say, well, a compile time, oh, they're the same, but really they're the same at only one level, the type. The name is different, their value is different, their position in the file is different, and yet the only handle I've got on comparison is type, and one useless thing in this case. The other issue is, well, can I somehow avoid this T0 being evaluated twice? Well, I have to be able to match branches. Anyways, this is the hard problem I'm trying to solve. Anyway, comments afterwards would be greatly appreciated. This is my vague plan. Well, you could implement this in C, I think. It's got nothing to do with templates. You might use it with templates. I mean, it's useless on its own, but you can do it without templates. So I do it in C, then if that worked, I do it in D, and then if that worked, I'd write a paper on it, and then if that was of interest, then if the paper was accepted, then I'd try and push it a bit more. And that's the end of that.
Okay. I'd like to welcome the next speaker up. I hope he's here. Oh, it's me. Okay, get straight into it then. So, this is a composable command line parser. You might be wondering what composability and command line parsing have in common. Turns out quite a bit. We'll get to that. But first of all, I want to talk a little bit about Catch, my test framework. If you've used Catch, you know that it has a fairly rich command line parser built in. You've got lots of options you can set. This is the complete list as it currently stands. You've got short and long options. You've got this sort of nice description on the right-hand side, all nicely formatted if you get the help on the command line. But it wasn't always like that. And actually, if we just go back in time for a moment, look a little bit at the timeline of Catch. Originally, this was just a very ad hoc command line parser built in, just basic string compares, sort of thing you might start on any new project. Of course, as time went on and I started adding type conversions and error handling, and that's some nice formatting for the options. It became more and more general. In fact, it became so general that by the time I released Catch 1, I realized I had a fully fledged command line parser built into it, embedded in it, if you like, and I spun it out as a separate library. It's called Clara, for Command Line Argument Arranger, I think it was. It's a bit of a backronym. But that never quite reached 1.0. There's a few little problems with it. I mean, it works fine for Catch. There's a general library, a couple of slightly dead-end design decisions in retrospect. And of course, like Catch itself, at the time, it was constrained to C++ 98.03, which was quite limiting. So the Catch 2, which is still imminently to be released, rebased on C++ 11, I've taken the opportunity to completely rewrite Clara from the ground up, using C++ 11, embracing it, so lambdas and that sort of thing are in there, but also I've redesigned it around this idea of composability. What does that actually mean in practice? Well, let's have a look at how it's actually used. So this is a complete parser, just for a single option. So you can see it's like a bit of a DSL. So if I bring in the other bits, you can see what you do is you bind a variable, it could be a lambda as well, bind a variable or a lambda to a, in this case, just a little hint string. We're calling this an opt. Then you have the options themselves, kind of short and long opts, you can have as many as you like. And then you can have an optional description for printing out in the command line help. But when you introduce another parser as well, you can have as many as you like. You can actually compose them together using, if I can get this right, there we go, this operator here. That's where the magic happens, in this pipe operator. This is actually a type of monadic bind. And what's happening is, the input to one of these option parsers is, well, the argc and argv. In fact, it's wrapped in this args sort of lexer. It will make it like a stream of tokens. So you pass in the stream of tokens, and what you get back is the stream of remaining tokens and a status to say whether that completed or not, or whether there are any errors. If there were, they were. When you combine them using this operator, what it would do is if there were no errors, it would just forward the remaining tokens onto the next option. If there were errors, it would short circuit and give you back the error. And that's all there is to it. That's how you compose them together. As a consequence, well, first of all, you don't actually need these intermediate variables. Of course, you can just compose them all in one go. So you only ever get the composite parser. You can add additional ones. So as well as ops, you've got args for positional arguments. And that's how catch itself defines its command line now. That's the complete set. Hope you got all that. You can see at the end there, it's returning that composite parser. And in fact, you can get to that in user code. And this is where it becomes useful. So in catch, you can get catch to generate main for you, or you can take control of main. And you've got a few places you can hook into. And now what you can do is you can grab that command line parser that catch itself produces. You can compose it with your own options, bind it to your own variables that catch knows nothing about, pass it back into catch, and it will just do it all for you, or rather Clara will. And then you can just access it at the bottom. And it'll even print that in the command line help, automatically all done for you, all the formatting, no extra work required. And this is one of the long-standing, outstanding issues with catch, how to take control of the command line, still pass things through to catch. It's now trivial. And if you've got your own application that has multiple components, each of which require input from the command line but know nothing about each other, they can now just expose their own parser and it can be trivially composed at the top level. So that's the composable command line parser. I'm Phil Nash, of course. You'll see more of me later. This week you can reach me and on GitHub under Phil Squared you can get Catch and Clara as well as a few of my libraries. So thank you for that. I shall now start here to introduce Tom and Tristan, who are going to tell us about C++ London University.
Hi, my name is Tom Breza, and this is Tristan. I would like to tell you about really amazing project which we are involved. It's C++ London University. I suspect everybody are familiar with the cartoon. Yeah? Well, no, this is me. Almost a year ago, quite a coincidence, I was decided to learn C++. And obviously, I wanted to do it quickly and know the C++. But I realized soon after that it is possible to do it in 21 days. So what I did, at the start, I started looking online. So I found online courses, Udemy, Coursera, and you name it. But these resources, they had some problems. Yes, they're very helpful, but they have some issues. And the issues are basically, they're not always complete. You cannot ask questions. Let's say you're stuck on something. You cannot just raise your hand and say, hello, I have a problem. Would you mind to help? No, that doesn't work online. So then I said, okay, I think that the solution to that is to go to the short courses. Like there are some in London. But then again, I hit the wall because 25 hours, 10 weeks, and it's a problem. The teacher, even if he have the best intentions, he cannot cover the whole C++ in 25 hours. So I said, well, it's not working. So I said, university. Well, I'm too old. It costs too much money. I have a family. I can't say, sorry, boys, I'm going for 3 years. I'll be back and I'll be the expert. No, it doesn't work. And I don't want to be a PhD in computer science for a reason that I want to learn C++. So I said, no, that doesn't work. Then I started researching and I found there is a meetup. So I started going to the meetup and I met Phil. I said, oh, I got a great treacherous idea. I will convince Phil to do C++ London. Well, at the end, he convinced me. So I said, okay, well, let's fire on. Let's try to do that. And what I try to do is, first of all, we have a lot of people, yes, lots of experienced C++ developers. They're a very friendly community. And I realized there's no place like that. So I said, okay, let's do C++ London University. And I started looking for the volunteers. And then I came across Tristan, and Tristan basically can tell you a bit more about what we've been doing and what we managed to do so far.
All the way back. I can't work the clicker, never mind. Yeah, so as Tom says, I volunteered as a tutor. Didn't really know what I was getting into, but it's been good. So when I was thinking about how do I want to teach C++, and I don't know how many people have seen. There's a talk by Kate Gregory, I think from CPPCon, called "Stop Teaching C." It's really, really good, and it really says, don't start off talking about pointers and arrays and all that nasty stuff. Start with the good stuff. So the philosophy really was teach modern C++, not even C++ 98, but 11 and 14. So yeah, RAII, auto, range-based for loops, all that good stuff. And secondly, we wanted to be hands-on, right? So the best way to learn to program is by writing computer programs, right? So I liken it to learning to play the piano. The only way to get better at learning to play the piano is by playing the piano. You can read all the books on music theory that you want to, but it's not actually going to improve your playing. So to that end, the format, it's been so far a mixture of sort of lecture-style slides and me talking, like I am now, and a lot of exercises. So we've really tried to get people involved. We've had 4 meetings so far. We've got about a dozen regular students, a couple of them in the audience tonight, which is really nice to see. And yeah, they're real range of abilities as well. So everyone from someone who's not written a line of computer code before, all the way up to people who've formerly used C++ professionally sort of 10 years ago and want to freshen up their skills. So they've been really good. We had some really good feedback from the students as well. And yeah, I want to thank Myriad, who've been hosting us on Tuesday evenings, and to Jackie and Phil and Ollie, who've turned up and helped out. And to that end, actually, if you think this is a great idea, we'd love you to come along. Probably you guys, if you want to become tutors or help us out, if you've got some great ideas for what you could pass on to beginners, that'd be fantastic. So come and talk to me or Tom afterwards, or you'll see our contact details in a minute. That'd be awesome. Or spread the word if you think there are people who want to learn C++. Let them know. And yeah, did you have any closing remarks?
Yeah, I mean, the idea is for us is to create a situation where the tutor can be another class, for example, a student. Let's say if you are good at something, you might not be necessarily extremely good at something else. So somebody comes along and teach you, for example, something about Git or something else. Some people, from what I know, they're coming from different languages, or you're stuck, let's say, in an older version of C++. You would like to learn about C17, let's say, or C14. And it's much better to do this with a group of really nice people, or you can do this, let's say, somewhere in, I don't know, small closet with small window and bit of light and candle, yeah, like the monks did in 14th century, or, among their friends. That's what we're trying to do, yes? And the great thing, there was on the previous slide, we're doing this for free. Yes, so quite compelling, I hope. So if you're ready to join us, come talk to us.
Thank you.
Thank you, Tom. Thank you, Tristan. So, actually, before we move on, I just want to say that I joined them this week, and it's a really humbling experience to actually sit down with people that have often not programmed at all before, done very little, and actually seeing them working this stuff out for the first time and helping them along the way. So, really recommend everyone to try and make some time to drop in on one of these sessions and help out.
If you want to help us out, it's a really rewarding experience as well for the tutors to see that moment where the light bulb goes on in someone's head.
So thanks for that. We're going to move on here. We've got Ian next to talk about automatic differentiation again in C++, slightly different tack, I think. So I'm going to pass over to Ian now.
Thank you. Okay, so more automatic differentiation, following on from Dominic's talk. I'm going to try and convince you that automatic differentiation is actually really simple and is actually quite successful in getting quite a lot of traction because of how useful and how simple it is. But in motivation, automatic differentiation is useful for mathematical functions, so working usually on real numbers in whatever domain you happen to be in. So here's a simple mathematical function. We've got a triangle. Let's say we know how long its bottom axis is and how tall it is. We would quite like to know how long the hypotenuse is as well. Maybe this is the distance to a monster in a game. Luckily, there's a way of calculating that distance z based on the length of x and y. So what we say is that there's a function relating z to those input parameters x and y. And in C++, this is fine. We can handle this. We'll use some double precision floating point numbers because they're really useful. And we'll write a nice function defines Pythagoras to give us the length. Now, that's great. That's really nice. It means we can evaluate our function and the length. But it's also kind of limiting. This is a black box once this is compiled up. All you can do is stick numbers in and it will give you back the answer. But a lot of the time from a mathematical perspective, you would also like to know some other information. And in particular, you'd like to know the behavior of this function nearby the point that you asked about, the gradients. So if I change x a little bit, what happens to z? There's a lot of problems where that's extremely useful, basically essential. So our simple function here, we can call it with doubles and we can get the answer out. That's brilliant. If we want gradients, we need to change tack a little. So let's take the doubles out and embrace duck typing instead. So we're going to template that type, and instead of specifying we're going to use double precisions and put those in, we'll just say any type you hand me, as long as you define what square root means, what times means, and what plus means, that's fine. I will handle that. And that then allows you to do all sorts of cool tricks, automatic differentiation just being one. So in its simplest form, we can still call it with doubles, that's fine, still gives us the right answer. But we can also define types which will keep track of the derivatives as they pass through the function. So this is a simple type of automatic differentiation called forward mode automatic differentiation. And here I'm using an implementation from a package called Sheret, which is basically a least squares solver for large-scale problems, which uses this technique. So just to explain what's going on, instead of defining doubles, we're using these jets instead, but we still set those to the same thing. So we set x to 3 and y to 4, just like we did before. There's a bit of housekeeping just to say this is a function with 2 parameters, so please keep track of 2 derivatives as you pass through it. And x is the first of those parameters, and y is the second of those parameters. But obviously starting from 0 because we're in C++. And so when you call that function, you can then, as well as getting the answer from it, retrieve the gradients. So that's the derivative of the function with respect to x and the derivative with respect to y at the particular point that you inserted it. Okay, does anybody care about this? Yeah, actually people do. Don't shake your head. People do care about this. What it buys you, and I think it has got quite a lot of traction in recent years, particularly in 2 fields. So in model fitting, large-scale model fitting, like if you've got multiple cameras, like in Street View, you need to match points between those images and work out where the cameras were and where the points are in 3D space. Automatic differentiation is used very commonly in that application, and also in a slightly different way within machine learning, stuff like TensorFlow libraries using reverse mode automatic differentiation, which I have no time to talk about, but suffice to say it is a widely applied technique. The reason it's popular is because it's fast, it's efficient, it's accurate, and it's much better than the old alternatives of doing all this stuff by hand or trying to poke small differences through doing finite differences. So yeah, that's it. Thank you very much.
Okay, so got Andrew Gresyk up next. Now, it's going to do a little bit of switching over here. Bear with us.
Right. My name is Andrew. I'm a senior programmer at Spark and this is the postmortem for the programmer interview process change I was a part of in the last few months. As we've now had a career-focused talk at the Meetup, I'd be interested to know whether there is a demand for that. So if you could raise your hands if you're involved in the interview process yourself. Right, quite a few people. Or you're interested in this from a candidate's perspective. At some point, all of us are candidates. I actually nobody. Look, a couple of guys. Interesting. So what is a screening interview? Usually, it's a short, 1 hour long interview done via Skype using screen sharing. And this is the initial evaluation of the candidate to determine if it's worth doing the full technical interview on site. And this is roughly the place for the screening interview in the hiring process. There are two major points to cover. We need to evaluate whether the candidate is a good fit for the project, the team and the company, and also determine if they have the skills needed to do the job, or potentially both, and in which order if both. All the details. Previously, our process consisted of 1 hour of cultural fit interview and 1 hour interview dedicated to technical questions. And what we found is the average caller candidate in London is a reasonable human being that communicates well and generally is a nice person. And very few of them actually fail the cultural fit interview. However, quite a few of them are good at C++, unfortunately. Which led inevitably to a lot of wasted time. We also learned the hard way that only asking questions during the technical interview often leads to us missing gaps in candidates' important skills. And we can agree that communicating with the nerds that we all are is not always easy. There are a whole range of human factors that have major impact when talking to a human being. And most of them weren't helping us accurately determine the candidate's skill. On top of that, some candidates are really good at selling themselves. And occasionally it turned out that their ability to sell themselves was inversely proportional to their abilities. So for solutions, we decided to save time by first swapping the technical interview and the cultural fit, potentially, or maybe even combine them. To reduce the impact of a human factor, we experimented with giving candidates practical tasks instead of just asking questions. And we define our priorities and build the plan to satisfy them. We were always building the team for the long-term human engagement, and cultural fit has always been more important for us than specific skills. And this also makes sense from the teaching perspective. While programmers can relatively easily learn new specific skills, personality traits are almost impossible to change. And when it comes to evaluating skills and abilities, it's faster to check for the specific skills than more general ones. Now that we had our priorities, we came up with a plan. The plan looks like this. First, we check C++ skills by giving people a practical C++ exercise. Then we ask follow-up questions to cover general programming skills. Then we'd give a specialization exercise. And while doing all of that, we'd also look for red flags to evaluate cultural fit. And in the end, we'd leave 5 minutes for the candidate to ask us questions. And this is roughly how it would look in terms of time. So this is how we do it. For C++ exercise, we would ask the candidate to write about 10 lines worth of useful code, some minimal algorithm. We'd ask for our questions as they present a great opportunity to cover a variety of general programming knowledge. Candidates rarely fail there, and usually after that we have a better understanding of their seniority level. And for the specialization exercise, it could be for render programmers, write a shader, or design a multiplayer gameplay feature, or explain animation timings and such. And the results were great. 80% of the people that fail do this in the first 15 minutes. And that's great, because no more wasting time for us, no more wasting time for them either. I want to point out that a very subtle effect of stress reduction if the candidate passes the first exercise. Stress goes down significantly both for you and for them. And you are no longer concerned about potentially wasting time, and they get a little bit of confidence boost. Cultural fit is still evaluated through the entire course of the interview, and there's plenty of opportunity to watch out for red flags in communication. Minimizing human factor in practical exercises helps us reduce overall stress levels and increase perceived fairness, which is super important. We found programmers usually like coding, so they enjoy exercises a lot more than just questions. Follow-up questions often lead to engaging conversations later. Our confidence in evaluating candidate skills has improved dramatically. So this is a baseline for the mid-level programmers. For the juniors, we slightly tailor this and focus less on evaluating the skills and more estimating the growth rate. For the seniors, the structure works fine, except it takes longer because we want to dig deeper. And it makes more sense to spend more time to cover a wider range of topics. Some people are naturally good at interviews, and I'm not one of them. So if you like me, prepare. Transform your priorities into a plan with timings and follow it. Experiment. And remember that interview is a two-way street, and for the candidate, you are the company, and do your best to make sure they enjoy the experience. And lastly, if you're interested in making games and get paid for that, please check the link below. And that's it. Please do let me know, or Phil, if you'd like to see more of career-related talks. And also, if you don't, do that as well. Thank you.
If you do want to apply for a job with splash damage, you now know what the hiring process is like, so that can be useful. Let me switch back to Keynote. Hopefully nothing will go wrong this time. Okay. That's what it's supposed to do. Right. Okay, so next up we have Jamie Taylor, who's going to speak about Beyond SSO, that's small string optimization, the merits of fixed length strings. And just a funny little story about this. When I was putting these slides together, I'd copied this slide hundreds of times because of all the animations. And it was only later I realized that I'd actually cut this string off just before the end. So it said fixed length string. So there's one character too few. So I thought it was quite appropriate given the subject. So I'm going to hand over to Jamie now, who's going to talk to us about fixed length strings.
I noticed, by the way, straight away that you cut my title off. Right, anyway, so very quickly going to talk to you a little about fixed length strings. So let's just jump straight into it. So, you know, we're not uncivilized heathens, C programmers. So we're all pretty familiar with standard string, you know, and it's pretty damn nice, really. We've, what have we got? We have our memory allocation. That's all handled for us. No allocating arrays, passing them around, and so on. The code to actually work with them is much cleaner. And we benefit from the short string optimization, which for anyone who may not know, means that any strings under a certain length will just stay local to that string instance. There will be no dynamic allocation to hold them. So standard string is pretty damn good, but it's not perfect. No laughs, really? No? I thought you people were nerds. Right, anyway, so SSO, as awesome as it can be, it is implementation defined. The length of the SSO buffer is implementation defined. Even the presence of the SSO buffer, if I recall correctly, is implementation defined, which means if your string is too long for SSO, you will dynamically allocate. If there is no SSO buffer, you will dynamically allocate. And it doesn't matter if you want a 1, 2, 4, 8, 16, 10, 24 character string, especially if you only have a short string, then you will have to pay for the size of the entire string instance, which is often 32 bytes. So suddenly your 4-character string, null terminator included, costs you 32 bytes. And Kurt doesn't like that. So Kurt has asked me to talk to you about FL string, aka fixed length string. FL string is a fixed length string implementation I'm working on. There's still a lot more to go, but I would like to eventually implement the whole standard string interface. But anyway, we can see on the left, for example, this is what your typical standard string might look like. You have your length, the capacity, which is the maximum amount of characters you can get in the currently allocated space. And you have your implementation-specific SSO buffer. So you can see in this scenario, I have a 3-character string. Let's say in my application, I know the string will not go over 8 characters, right, including the null terminator. So 7 for me to use. You can see what I'm talking about when I point to the standard string and say, even though I will only ever use a maximum of 8 bytes, I'm paying 32 bytes for this string instance. And this is not terribly optimal in some scenarios. So we have fixed length string, which has a static array of the character type of the length that you pass in at compile time through the template parameter, and you can simply maintain interoperability with standard string via string view. So let's have a look at this puppy. Common string operations, we have construction. I've yet to meet the programmer that doesn't use this one. And really? No credit, no laughs? No? Damn. Better not quit this job. Right, and we also have assignment, and we have concatenation by the plus equals operator. And I've ran a bunch of benchmarks over G++, Clang, Visual Studio, so on, with 8 and 32 character strings. That includes the null terminator. And we can see that for 8 and 32 character strings, respectively, you get a 6 and 13 times speed up in these operations. But let's go to something that you might be a little more likely to actually see out in the wild. Let's take a unordered map with string integer pairs, 128 of them. The integer simply counts how many times you've searched for that particular string, but it could be anything. So let's record the time taken to create the map and perform 256 randomly generated lookups. So let's have a look. And we can see straight away that through both map creation on the left and map access on the right, fixed length string has a consistent advantage in that it is much faster to create, and it is it is faster to create the map, and it is faster to access the map. And also keep in mind that when I say 4-character key, I'm only paying 4 bytes instead of 32 for a standard string, which is also much more friendly to your cache. So let's have a look at 8-character strings. No, what is your clicker doing to me? There we go, 8-character strings. And we can see that the lead fixed length string has over standard string is opening up a lot more now. We can see considerable and consistent advantages with regards to map creation time and map access time, regardless of compiler, 4 keys, 8 keys. Oh, yeah, it's pretty awesome. Right, anyway. So to conclude, please, the takeaway points. Standard string is not necessarily the be-all, end-all. It's not a perfect fit for all scenarios. It may dynamically allocate. For short strings especially, you pay for the price of the entire string instance. So fixed length string by comparison offers complete control over memory. You never dynamically allocate. You only pay for the space you need, so you have better control over your cache. And the last byte also stores your remaining capacity. I forgot to explain that. It restores your remaining capacity, and as the string grows, it decrements, and then when the string is full, your null terminator is also doubling up as a remaining capacity of 0. So that's also quite nice. And as you've just seen, you have demonstrable performance gains, not only in common string operations, but also in things that you're likely to see out in the wild, maps, and so on. So if you're in embedded or games or trading, if low latency and every byte matters to you, then please, consider a fixed length string. Thank you.
There we go. So, still managed to get an extra character in there. All right, so thank you, Jamie. So finally, we have Vittorio here, who's going to type it out 3 times for us.
Thank you, Phil. So, my name is Vittorio, I work at Bloomberg, and you must type it 3 times. Let's look at this talk from the perspective of a library developer. Your user has some foo function object, which has a complicated noExcept and some complicated return type. And you, as a developer of some very useful library, you want to provide a generic wrapper that maybe logs something and then calls an arbitrary function passed by the user. So this is my first attempt. I have this function which uses STL type auto to return correctly references or whatever the user will give you from his function. Then it takes a function, a bunch of arguments, both by forwarding reference. It logs something, and then it returns the function invocation, forwarding both the function and the arguments to the function. Any issues here? noExcept. noExcept is missing, and if we try to invoke new noExcept operator, onto our wrapper, we will see that it will always evaluate to false, and that might not be the case for the function provided by the user. So we have a mismatch here, which might matter. So this is the second attempt, and I have this beautiful no except thing here, and I'm checking whether the invocation that I'm making inside the body of the function is no except, and thus I'm propagating the no exceptness of the user provided function. So
I'm scared.
Issues? It's not const expert. Yeah, we'll get to that in the next slide. There is a bigger issue here. What? Yes, it's not Spinai friendly. What does that mean? If we try to use is invocable or is callable, depending on the version of your SAM library implementation, onto our wrapper, it might behave differently from the user provided function. It might actually generate a compiler error, which we cannot use to spinai away our wrapper, but we could do the same with the user provided function. So what's wrong? Why is it producing a hard error instead of getting silently spined away if we have an overload set? Well, the problem is that if we say decal type auto, the body of the function, so the thing that we're going to invoke, is not part of the signature. And the error will be produced during the instantiation of this wrapper and not in a place where it's spinai friendly. In order to solve that, we need to make the body part of the signature. So what we can say is decal type of the expression that we're going to invoke inside the body, and now we have this fantastic thing. There is one more issue, which was pointed out by Gaspar, is we're missing const expr. So we want to make sure that our wrapper is const expr if the function provided by the user is. So we also need a const expr in there. Yeah, that should be it. It's pretty nice. Works very well. There is another issue. I had to repeat this thing 3 times, literally copy-paste it. I find it very annoying. And I wonder, why can't the compiler do this for us? Well, if we use the preprocessor, we can do something clever. We can define this returns macro, which takes any amount of tokens and generates for us the no except specification and the trailing return type by simply passing the tokens inside those specifications, and also will return those same tokens. So if we say something like this, returns the log, and using the comma operator here, and then the body of our function, it will generate everything for us, and it will be no except correct and spinai friendly. So if you compare it, I'd rather write the version on top. Unfortunately, this is still not great because we have a macro that will be exposed to the clients of the library unless you go in every file where you define something and then undef if after the function, which is quite horrible. And it assumes that something will be returned. So it only works with expressions. As soon as you have something like an if statement, you're pretty much screwed unless you find a way of using a ternary operator. It doesn't play nicely with void. You can solve that with programming, but again, it's still annoying. And you have to use the comma operator or something similar to simulate compound statements. Why can the compiler do this for us? So there is a proposal by Barry Resvin called Abbreviated Lambdas for Fun and Profit, which proposes this new funky fat arrow syntax. And the proposal says that if you have a lambda, like this one, and use the fat arrow in an expression, the compiler will expand it for you to exactly what we've seen before. The no except, decal type, and return with what's inside with the expression that follows the fat arrow. So this is going to be discussed at Albuquerque. Has been through a few revisions, I think 3 revisions, and hopefully we will get this inside of the standard. But this fat arrow thing could be useful for normal function as well. Why just lambdas? So this is my dream pseudocode. We simply put an arrow before the body of the function and we get everything for free. The issue here is that basically we don't have a way of passing a compound statement to the no except operator or the decal type. That's currently ill-formed. So we might have to think about a way for the compiler to split compound statement into multiple specifications of no except and decal type. For example, if we pass a compound statement to no except, we might have some rule in the standard that says that it's equivalent to doing an AND operation between the no except of the first statement and the second statement. And we can do the same like with an if. In this case, we don't really have a condition anymore if we expand it. And we can basically define a set of rules that will work for every language construct. So you could have some sort of crazy stuff like decal type with an if const extra inside it. So now the return type has to be conditionally evaluated at compile time. Now this is more tricky. Maybe you would have some sort of conditional decal type language construct or implementation detail in the standard. But I don't know. I'm just dreaming. Maybe this is impossible due to implementation difficulties. But I can dream. I want to write this and I want to copy paste the thing 3 times. Until then, you must type it 3 times.
So, that brings us to the end of our series of lightning talks in London. Thanks again to all the speakers, for everyone, and also to everyone in Stockholm and all the speakers there. I think this has been a great success. Don't know about you lot, but I know there are a number of other groups are keenly waiting to see how this is going to turn out, to see whether they're going to try the same thing themselves. So let us know what you all thought, but I think we'll probably do something like this again. So thanks everyone here, and thanks everyone in Stockholm for listening, and we will see you next time.
Something I'm going to take also, I will speak a bit to close this meeting. So, yeah, there was a lot of amazing talks tonight. And I want to thank the speaker for it, as well as the people that helped us to organize, so the people in the group in London and in Stockholm, and also the people from King that that was there to help us. I think that you're gonna receive a survey, so please try to answer it. That will help us to improve this kind of distributed meetup concept. Since we are a bit early, I guess we could have an open discussion for the coming 15 minutes. So what I'm going to do is I'm going to ask the speaker to come on stage. If you have any question for the speakers, please come here and ask your questions. I think for London, you still have a bit more time to socialize. That will be also the case for Stockholm. But if you want to go in Stockholm, don't forget to give back the badges. But yeah, let's do this open discussion, and please, speakers, come on stage. And I guess this applies as well for the speaker in London. If we can get the camera to the London stage.
London stage? Sure. No, let's turn that around. That's a question. Might have infinite.
Can you give? So we will start with Sweden. As anyone in Stockholm or London have some question for someone in Stockholm? Any question?
I have a question.
Yes. So someone has a question for Phil, so I can pass it to Stockholm. Please come in front of the camera.
Can you hear me? Yeah. When is Catch 2.0 coming out? I've been waiting.
Well, I mean, it's out in beta now. You can get it on GitHub. It's pretty stable. Still just trying to finalize a couple of things before it gets locked down, but very soon. That's all I can say.
Cool, thank you.
Any other question for London? Maybe someone in the London audience? No question? Then I guess we can end up this open session. Have a good evening.
Thank you.